All right, let's look at the homework 16.7, problem number 6. All right, so let's look at this problem. All right, so we want to evaluate this surface integral, and the f is given here, and s is a cube with vertices plus or minus 1, comma, plus or minus 1, comma, plus or minus 1. All right, so I already drew the cube, so which looks like this. And obviously you can have, let's see, 6 sides. So we're going to have to look at each one of them. All right, so let's do that. So we have an integral over the surface of cube S. And then f dot, right, normal vector, and ds. Right? So we're going to split this into 6 parts, 6 integrals. So it's an integral over S1, right? All right, so let's look at S1, right? S1, x is equal to 1, right? So the integral is going to be, right, x is already 1, and you have a 5y is the second component, and a 3z, right? But in this case, the normal vector is pointing in the positive x direction. So the normal vector is just the vector I, right? Actually, I'm going to write it as vector I is it's a 1, comma 0, comma 0, right? Then we have a ds, right? So you can see that this is actually come out really nicely because here, this integral, this dot product is going to be 1 times 1 plus 0 plus 0. So this is just going to be equal to 1. All right? So we're going to do the same, similar thing. So let's look at integral, right, S2, right? So S2, normal vector is a j vector, so it's going to be 0, comma 1, comma 0. And in this case, y is 1, so you have you're going to have just a 5. So this is going to give you 5. So we do the similar computation, but you're going to get 5 here. You're going to have a 1 here, so you're going to get just 5. So you have a ds, right? And plus, let's look at S3. Right, S3 is right on top, so it normal outer normal vector would be a k vector, right? So vector k. So and again, z value is 1, so it's a 3. So you're going to have a 3 ds, right? Plus, right? So let's look at S4. So you have S4, right? At S4, S4 is the back side here. So the outer normal vector is negative I, and the value of x is negative 1. So you have a negative 1 times negative I, so it's going to give you a positive 1. So it's going to be 1 ds, right? And then look at the double integral over S5. Right, S5 is this one right here. So it's going to be a negative j times, right? So at that point, y value is negative 1. So you have a negative 5 times a negative 1. So it's going to give you a positive 5 ds. All right, so last one, S6, which is the bottom one. So the outer normal vector is negative k. Right? At this point, the z value is negative 1, so this component is going to be negative 3 times negative 1, so it's going to be positive 3 ds. Right? So since this is just a cube and each side is a 2 by 2, so area is going to be 4. So we can see that here, this is just the area of S1, which is 4. Right? Plus this is the area of S2, which is 4 times 5, so it's going to be 20. Plus This is 4 times 3, 12, plus 1 times 4, it's 4. And then 5 times 4 is 20, plus 3 times 4 is 12. Right? So if you add them all up, you get, let's see, this is 24, and 36, 40, and 60, 72. So we got 72. Right? Let's type it in. So we got 72. Let's see. Let's type in 72. Right? Submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.